everything we have ever built and every single star you see in the night sky has an expiration date. Right now we are living in the golden adolescence of the cosmos, a brief, vibrant window where stars shine and life can actually exist. But this window is closing. In about 5 billion years, our own sun will run out of hydrogen fuel. Its core will collapse and its outer layers will expand into a massive red giant, swallowing Mercury, Venus, and likely the Earth. When its outer layers finally drift away into deep space, only a glowing ember will remain. A white dwarf. A dead remnant, slowly cooling in the freezing temperatures of an expanding void. But the death of our sun is just the very first second on the cosmic clock. What happens when all stars die? Welcome to the Degenerate Era. Trillions of years from now, the universe will completely stop producing new stars. The cosmos will enter a permanent twilight, illuminated only by the corpses of dead suns, white dwarfs, neutron stars, and black holes. For trillions of years, these zombie stars will drift through a ghost universe. But even they cannot last forever. White dwarfs will eventually lose the last of their residual heat, cooling down completely to become black dwarfs. These are dark, dense, decaying spheres of degenerate matter ashes of stars so severely crushed that they are 1,000,000 times denser than our sun. Because it takes hundreds of trillions of years for a star to cool down this much, there is not a single black dwarf in the universe today. They belong entirely to the future. As time stretches into incomprehensible numbers, the very fabric of solid matter begins to unravel. According to advanced physics, protons, the fundamental building blocks of atomic matter, are not completely stable. Given enough time, they will spontaneously disintegrate. This means that any material that manages to evade the gravity of a black hole will simply dissolve. The matter trapped inside those frozen black dwarfs will slowly evaporate away, atom by atom, disappearing into the void. When the last proton decays, the physical universe as we know it ceases to exist. There will not be a single atom of matter left. All that remains of our once rich cosmos will be stray particles of light and the ultimate apex predators of space, black holes. We now enter the black hole era. Timescales lose all human meaning. In this dark epoch, galaxies are replaced by supermassive black holes at the center, with smaller black holes orbiting them. For unimaginable eons, they will collide, merge, and feast on one another, sending massive gravitational ripples warping through the fabric of space-time. To us, it would look completely dark, but if you could listen to the universe, it would be a chaotic symphony of space-time, squeezing, stretching, and ringing like a drum. But physics dictates that even these titans are mortal. Through a quantum phenomenon known as Hawking radiation, black holes slowly lose mass. For a long time, this mass loss is agonizingly slow. But as a black hole gets smaller, it radiates energy faster and faster until it vanishes in a final cataclysmic explosion. One by one, over Google years of time, every single black hole in the universe will pop out of existence. And then the final epoch arrives, the heat death. Driven by the mysterious force of dark energy, the universe will expand out of control, becoming infinitely cold, dark, and empty. The cosmos will be reduced to a faint, uniform sea of photons, gradually cooling toward absolute zero. For the first time in its history, the universe becomes permanent and unchanging. Entropy finally stops. Nothing happens. And it keeps not happening forever the story of our universe comes to a definitive end. But as we look out into the night sky today, seeing the stars still burning brightly, we are reminded of just how extraordinarily lucky we are to exist in this brief, beautiful flash of light.